Welcome back to our IB Chemistry video series. This is the first video in IB Chemistry Topic 7, Equilibrium, where we will be looking at reversible reactions, equilibrium, Le Châtelier's principle, and impacts on equilibrium. As you will know from your GCSE or MYP years, some chemical reactions are reversible, i.e. the products and reactants can interconvert via the same reaction. Such reactions are denoted by a double-headed arrow. For example, H2 plus CO2 goes to H2O plus CO. Since the forwards and reverse reaction are unlikely to occur at an identical rate, you can therefore consider a reversible reaction as a balance between these two reactions. Eventually, a reaction will reach a suitable balance between the two, termed the position of equilibrium. Equilibrium is therefore defined as the position of a reaction in which the concentration of both the products and reactants remains constant. The position of equilibrium varies for every reaction. In some it lies closer to the reactants, and in others closer to the products. There are a few important facts to know about any reaction at equilibrium. It can only be obtained in a closed system, such as a container. No changes appear to occur, i.e. the macroscopic properties remain constant. Whilst the concentration of products and reactants remain constant, they are not necessarily identical to one another. There are two types of equilibrium commonly discussed in the IB chemistry exam: dynamic equilibrium and phase equilibrium. Dynamic equilibrium defines an equilibrium where the rate of the forwards reaction equals the rate of the reverse reaction. Phase equilibrium defines an equilibrium involving the change of phase, for example, bromine liquid going to bromine gas. In both, the product and reactant concentrations stay the same. Hence, we say that the macroscopic properties are constant, even though the reactions are still occurring. But how does one obtain equilibrium? Well, it can be obtained from either side, i.e. one could start with only reactants or only products. It is worth noting that regardless of the approach, the species present at equilibrium will always be all those present in the stoichiometric equation. However, their concentrations will depend on the starting concentrations of any products or reactants. Since equilibrium is a careful balance, it stands to reason it could be affected easily. Le Châtelier's principle is used to predict the effect of such influences. The principle states that a reaction at equilibrium subject to a change will shift the position of equilibrium in the direction as to minimize the effect of this change. You need to commit this definition to memory, as it is necessary for many long answer questions. The easiest way to think about it is that a reaction at equilibrium subject to change will move equilibrium in whichever direction opposes the change. But what changes can affect equilibrium? Well, for your IB chemistry exam, there are three you must recall. These are temperature, pressure, and concentration. You need to be comfortable stating and explaining the impacts of each of these factors with reference to Le Châtelier's principle. Let's go through them. For temperature, it is important to consider the effects separately for endo and exothermic reactions, a classification introduced in our IB Chemistry Topic 5 video series. For an exothermic reaction, such as CH4 plus 2O2 goes to CO2 plus 2H2O, we can say, since it releases heat in the forwards direction, it is hotter on the right-hand side. Thus, an increase in temperature would cause the position of equilibrium to shift to the cooler side, i.e. the left. By extension, a reduction in temperature would cause the position of equilibrium to shift to the right. For an endothermic reaction, such as N2 plus O2 goes to 2NO, we say since it takes in heat in the forwards direction, it is colder on the right-hand side. Thus, an increase in temperature would cause the position of equilibrium to shift to the cooler side, i.e. the right. By extension, a reduction in temperature would cause the position of equilibrium to shift to the left.
You've now reached the end of the preview for this IB Science video. If you want to check out the full video, head over to our website and select a membership plan today.